Theorem 1.1. It is a fundamental theorem of arithmetic. Okay. See, to understand this, you should know exact difference between prime number and a composite number. What is a prime number? See, I'll tell you. 5. 5 is divisible by 1. 1 will divide 5. 2 will it divide 5? No. 3 will it divide 5? No. 4 will it divide 5? No. 5 will it divide 5? Yes. Means what? If any number is divisible by 1 and itself, such numbers are called prime numbers. Okay. Example, you take 5. 5 is divisible 1 and 5 only. Then if you take 7, 7 divisible by only 1 and itself. And 3 is there, 3 is divisible by only 1 and itself. Then 2 is there, 9. 9. What do you think? No. Correct. 9 is not prime number. Why? I'll tell you. See, 9 is it divisible by 1? Yes. 9 is also divisible by 3. 3 3s are 9. Then 9 is it divisible by 9? Yes. So 9 cannot be a prime number. Okay. So I hope you understood this. What is a prime number? Now, once again, quick revision. What is that? A number which is divisible by 1 and itself. Example is what? 5. Good. That's it. So then what is a composite number then? What is a composite number then? A number which is having more than 2 factors. Okay, that is the actual meaning. But if I say that, you won't understand. If it is not a prime number, then it is a composite number. It will be easy for you to understand. Okay, then you can Google like that. What? If the number is not a prime, then it is composite number. You can take like that. Most of the times it will be correct because we have to exclude 0 and 1. Okay, so 0 and 1 comes under exceptions. That is the reason. So what this fundamental theorem of arithmetic says, see, when I say composite number, what is composite meaning? Which composes, which consists, which contains. Okay, na? So composite number contains prime numbers in it. Composite numbers contains prime numbers in it. You're not understanding? I'll tell you. See, prime factorization, what they say is every composite number can be expressed in the form of prime numbers. Still you'll not understand. Wait. Example 70 you take. 70 is divisible by 10 also, 5 also. You can easily tell that it is not a prime number. 70 is a composite number. So what I do now? Prime factorization. I think you might have forgot that. You have already learned in previous classes. Prime factorization means what? You will keep dividing the number by only prime numbers, or what is that? 2 power n or 3 power n, like prime number power n. With that number you are going to divide. So whatever second part I told, you will not understand. Just like you should keep dividing the number by prime numbers. Okay, 70 is there. So what are the prime numbers that you know from the starting? 2, 2 is a prime number, 3 is a prime number, 4 5 is a prime number, 7 is a prime number, 9 11 is a prime number, and it continues like this. Okay, prime factor is what you should start dividing the number continuously with only prime numbers. Okay, I will show you. So first I know 2 tables. So 2 3 times 6, 1 is remaining, 10. So 2 5 times 10, right? So again further I will divide it with 2. Is it possible? 3 5. Good. So now 5. 5 7 times 35. Now again further you should continue this process till you get last one. Okay. Then further 7 you got it. Is it divisible by 2? Is it divisible by 3? Is it divisible by 5? Is it divisible by 7? Yes, got it. So 7 ones are 7. This is what we call it as prime factorization. Don't worry, I will tell you the theorem. Don't worry. So what is the meaning of it? See, 70 I can express as 2 into 5 into 7. Correct na? See, 2 into 5 into 7, if you multiply, you will get 70 na? So what this theorem, fundamental theorem of arithmetic says? You can express a composite number, I will write. A composite number can be expressed as the prime numbers. A prime number into another prime number into another prime number. P I am writing it for prime numbers. Prime number 1, prime number 2, prime number 3. It continues. Yes, you can express a composite number as the product of prime numbers. Means what? Product of some prime numbers will give you a composite number. That is what they're telling to us with a proper sentence formation. That's it. That is not so difficult. Did you understand? You take any composite number, you take any composite number. Composite number means what? It should be not. It should not be a prime number. Okay. You take any composite number. And when you do prime factorization, arams you can express that number as a product of prime numbers. Still you did not understand? One more example. See, this time we take example of what should I take? Can I go with 12? Yes, 12 I will go. See, first I will go with prime numbers. Here are their list. First I will go with 2. 2 6 times 12. Further I can divide with 2 only. 2 3 times 6. Further I can go with 2. 3 is not divisible by 2. So I will go with 3. 3 ones are 3. Stop it. So means what? 12 is a composite number. See, that I am expressing as the product of what? 2 into 2 into 3. When you multiply, see, 2 is a prime number, 2 is a prime number, 3 is also a prime number. See, you are multiplying a bunch of prime numbers to get a composite number. Ulta they are telling. Every composite number can be expressed or can be written in the form of product of prime numbers. So now you read the definition, that is theorem 1.1, you will understand very well. See, now read. Every composite number can be expressed or factorized, or see, if you are getting confused with expressed and all, so you can just understand that every composite number can be written. This should. Every number can be written as a product of, so multiplication of prime numbers. That's what they're saying. See, that's it. This is the actual theorem. So extra information that they have given in the second, and its factorization is unique. What is the meaning of this, sir? Factorization is unique means what? When I say 70, factorization is what? 2 is to 5 is to 7. Correct? Means the factorization of 70 is 2 is to 5 is to 7 only. You won't get other pairs of prime numbers. Compulsory you should use 2 or 2. Compulsory you should use 5. Compulsory you should 5. See, compulsory means what? Like, you don't get any other numbers, other prime numbers, excluding 2, 5 and 7, which can express in terms of product of prime numbers as 70. Not possible. Only 2, 5, 7, only these 3 prime numbers give you 70. Other than these 3 prime numbers, you will not get any other prime numbers which will give you 70. That's what they're saying. What are they saying? 8 exclude, except 2, 5, 7, you don't have any other order. You don't have any other number pair of prime numbers. That's what that. It's unique. You won't get similar to it. You won't get another one. Okay. So that is the part they're telling. Apart from the order in which the prime factors occur, they just order doesn't matter. See, I'll tell you. 2 is into 5 into 7 is what? 70. If I change the order, will you get the different number? Like 5 into 7 into 2. Will you get some other number? No, no. You will get the same number, that is 70 only, na? Right? So that is what they are saying. Now, aram se you read the theorem 1.1. What is that? Every composite number, okay, can be written as a product of primes. You can write that number as, by multiplying the prime numbers. And this factorization is unique. The prime numbers which you are going to choose to express a composite number, the prime numbers which I will write there, prime number into prime number into prime number. So that is unique. You won't get same set with other prime numbers. You won't get. Okay. Order in which the prime factor. See, order doesn't matter here. As I said, 2 into 5 into 7 is 70 only. 7 into 2 is also 70 only. No, 2 into 7 into 5 is also 70 only. Order doesn't matter here. So something note they have given, what is that? The prime factorization of a natural number is unique except for the order of its factors. Already I have told you, and this is the factor. That is the same point. Very easy it is. See, these theorems are very important for you. Okay. Now when you are learning, spend some time, to analyze each and everything. Just for marks, don't study, I'm telling you. Okay. Try to understand. If you have any doubts, please write comment. Definitely I will be responding to it. Okay. So I hope this you understood now. What is the theorem 1.1 says? Very simple, man. You can express a composite number as, express means what, like you can write a composite number as the product of prime numbers. Yes. C is equals to P1 into P2 into P3 into so on. What are these P1, P2, P3? Are prime numbers. That is what fundamental theorem of arithmetics. Did you understand? Any doubts?